All right, let's see what we can remember from the last time. For those of you on the internet, we have been gone for 7 days, a new record. Never in the history of Oak Ridge schools have we been gone for 7 days.
And 2 hours.
So, 12.7. If given a polyatomic ion, I can draw the Lewis structure for it. I know that you guys do not remember what the heck any of this stuff is all about. The other 2 classes have very quickly caught on. So here we go. I'm going to do this one for you. First of all, what in blazes is this -2 here? We've never done one with a -2, so what I'm going to do is I'm going to scratch it away and ignore that it exists. Though you know as well as I do that there's probably a very good reason why it's there. All right. Sulfur is in the 6th column. Yes. Yes. Sulfur is in the 6th column. 6. Oxygen also occupies the 6th column. 6. And there are 4 of them. 6 plus 6 times 4 is 30. Who's in the middle? The one that you usually only have one of is in the middle. S. Around it, O, 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 O. We've gotten a, oh yeah, I remember this. Remember a dash represents 2 electrons. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30. 30. Okay, we've placed all the electrons. Now let's go and make sure that everyone has 8. This oxygen, 2, 4, 6, 8. Yes. This oxygen, 2, 4, 6, 8. This oxygen, 2, 4, 6, 8. This oxygen, 2, 4, 6. 2, 4, 6. 2, 4, 6. This sulfur, 2, 4, 6, 8. Okay, so we've got a problem right here. We're missing 2 electrons. Before we left on snowpocalypse, what are you guys calling it? Snowpocalypse. Before we left on snowpocalypse, winter break part 2. We talked about the fact that when you run out of electrons and somebody is not happy, you can
share.
Double bond. Double bonding is when you are bonded to somebody that has free electrons that it can share a couple or maybe 2 couples. So, oxygen is bonded to the sulfur. Does sulfur have a pair of electrons that it can share? No, it doesn't. That's what the -2 comes in. -2 means that you have an extra 2 electrons. So that means you did not have 30, you had 32. 32. Now is everyone happy? Are we done? No, because this is an extraordinary situation where this particle has picked up an extra 2 electrons. How do we communicate with somebody that we have extra electrons in this one? Does anyone remember? Brackets. Brackets, and how do we symbolize that we picked up 2 instead of 1 or 3? As simple as -2. Now, at this point, most people are happy and go, okay, I understand that. And that's it. They're not thinking about anything else. But there's somebody out there who's going, well, where did it gain 2 extra electrons? Somebody. There's a highly inquisitive person somewhere out there. Maybe this person right here, Ruth Hammond, is that person who was thinking, hey, where did those 2 electrons come from? Okay, so let me explain that to you. Have you ever heard of deadbeat dads? A deadbeat dad.
Yes.
What is a deadbeat dad?
Like somebody who doesn't care about his children.
Okay, somebody that doesn't care about his children. What does he do to his children?
Beats them dead.
No, doesn't beat them dead.
He abandons them.
Okay, it's a dad that has divorced mom. Mom has kept the babies, in which case the dad has to now pay child support. If he doesn't pay child support, then he is considered a deadbeat dad. So it's basically a dad who abandons his children. Hydrogen is the ultimate deadbeat dad. Hydrogen is the ultimate deadbeat dad. Okay? What does that mean? That means that probably the two electrons came from hydrogen. So hydrogen was here sharing its electron with this oxygen. So that was probably the state of this molecule originally. But what are hydrogens like? Deadbeat dads. So when the hydrogen takes off, it leaves behind its electron. And that is how we get sulfate with -2. The -2 probably comes from a hydrogen. Okay? Got it? All right. Let's try this one. Okay, I did one for you. Phoebe.
Okay.
Carbon, how many?
Carbon has however.
Which column is it in?
It's in the second trophy, so it has 4.
Oxygen?
Oxygen has 7 times.
Try again.
Wait. Oh, 6
Times.
times 3.
And what does the -2 now tell you?
That whatever you get, you have to add 2.
So, 4 and 2 is 6. So basically it's 6 times 4.
And that would be 4.
Who's in the middle? Who's in the middle?
Carbon.
And around it, oxygen, oxygen, oxygen. All right, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. Done. Hold on. Done. Phoebe, we're done. Is everyone happy?
No, carbon doesn't have.
Is carbon bonded to something that has a pair of electrons that it's not using? It's bonded to 3 oxygens that have pairs of electrons. So, which oxygen would you like to double bond with?
The left one.
The left one, because you're a liberal. I get it. Yes. You're a liberal.
Wait, do you just like, is it only one?
What? Aha. Do you just get to choose? By the fact that you have a choice tells you that this is an unusual structure. This is an unusual molecule that really does not have a liberal side or a conservative side or a libertarian side or a moderate side, but actually has a double bond that is flittering amongst them. Who remembers what word we use to refer to, Phoebe?
Resonance.
This is a resonance structure. So Allison, if you're asking yourself, well, which one should I bond it to? Then this is something that resonates. And the answer is, you got to draw them all. You've got to draw them all. Okay, first of all, is this correct? What's wrong with it? Phoebe, how do you communicate that this is an unusual situation?
You put it in brackets, and then you put a negative 2 beside it.
Okay. All right. Mr. Lenoir here comes from a family where medical doctor, so odds are He's conservative, and right now he is miffed. He is mad because we put the double bond on the oxygen side. Phoebe, he's mad. I mean, this is political correctness world. You can't just let him be offended. We got to satisfy him. So what are we going to have to do?
Switch with
All right, Mark, this is just for you. There it is. The double bond is on the right side now. Do you have? Yes, you do. You have to draw all possible structures. Why do you have to draw all possible structures? Because on the AP exam, you have to draw all possible structures. Well, why do you have to do it? I don't know why. I've taught the AP exam. I know you have to draw all possible structures or else you don't get full credit for it. If it was up to me, I would say, hey, draw one and put an R there to communicate that you know that it resonates. But it's not up to me, so I'm preparing you for the AP just in case you take the AP chemistry or you take chemistry in college. I'm preparing you for that. And odds are that what's happened is that the people who create the AP curriculum have consulted with college professors and they've asked them, well, should they include all? And they've said, yeah, we want them to include. So this is coming from the college level. All right. So Mark is satisfied. Phoebe's satisfied. What about you libertarians? Okay, there you go. Libertarians are people that believe that individuals should be the most powerful, that we're a bunch of individuals and the government is to work for the individual. So the government should be very limited and should only be doing what the Constitution says it should be doing. Okay? So people who are into drugs are going, yeah, libertarian, because the libertarians will say, hey, if they want to take drugs, it's their thing. They want to die, let them die. Okay? So, libertarians, here we go. Libertarians, who in some cases make Republicans look like liberals. In others, not really. It's really kind of an odd conglomeration. Make sure that the double bond should only have 2 pairs. All the others should have 3 pairs. Okay. That is the Lewis structure for carbonate. Yes?
For the structure on the oxygens and hydrogen have the 8 electrons, does it matter which pair you take away?
No.
Okay.
Right?
Yes. It's like Pokemon. Gotta catch them all. All right. Here we go. OH negative. You want to try to do this one, Alec?
Yeah.
O, how many?
6.
H, how many?
1.
What does the -1 tell you?
+1.
Can you add that up?
8.
Excellent. Who's in the middle?
Oxygen.
Okay, some of you are going to go, does it really matter? Actually, no and yes. No in that it's only 2. It really doesn't matter. Yes in that you must never forget that hydrogen is never in the middle. Why? Because hydrogen can only bond one time. If you put it in the middle, you'll be tempted to have it bond multiple times, which it cannot do. Those of you who played Tinker Toys, you know exactly what I mean when I say there were only some pieces that you could add as an afterthought. You could not use them in the main structure. That's what hydrogen is. It's only an afterthought. Lincoln Logs would work with the little man, that you put in at the end. That's it. Hydrogen is that little man. You have to wait till you're done with the structure, and then you put the little man. All right.
What's wrong with you, Ryan?
All right, here we go. 2, be careful. Because some of you, I guarantee this is going to happen because it always happens. Some of you are going to want to start with the electrons around the hydrogen, and you would be wrong. Remember, that's it. Hydrogen bonds once, and it's done. Once and done. Put the dots on the other guy. Alec, are we done?
Yeah. Well, we have to put the brackets around.
Very good. And?
Put a -1.
Yes. If it has gained or lost electrons, you must have brackets. When we last met 2 months ago before snowpocalypse, we didn't have brackets because we were dealing with just covalent molecules. They didn't have extra electrons or have lost electrons. Any questions so far? Phoebe?
This one's not a resonance one.
Okay, in order for it to resonate, you needed to have come to a point where you were asking yourself, well, which one should I bond it to? Did you ever get to that point?
No.
Yes?
Could it just be like outside of the brackets? Could it just be negative instead of negative?
Yes. Okay, SO2. Here we go. Who would like to tackle this one? Thank you, Natalie. Sulfur?
Well, I need my periodic table.
Oh yeah, I forgot to tell you guys, you need your periodic table and your calculators out.
Okay, so sulfur is
And oxygen?
cis.
And the 2 means?
That there's another one. So 12 plus 6. What's 12 plus 6? 18. 18.
She was kidding, Internet. She was kidding. She knew what 12 plus 6 was.
No, I
Yeah. Okay, now, question. Do we need brackets and a charge for this one? No, because this is not gaining or losing electrons, so no bracket necessary. Okay, who's in the middle, Nat?
Sulfur.
2, 4, 6, 8, 10, 12, 14, 16, 18. Nat, everyone okay?
No.
Who's not happy?
Sulfur.
Very good. So, is sulfur bonded to somebody that has a pair of electrons that it can share? Which one?
Both of them.
Well, you're going to have
Left.
to choose. So what does that mean? Because, Nat, you may feel more comfortable going to the left side, but what about Lenoir? Okay, he may be a liberal, but I dare say his dad is not.
Truth. Facts. I'm not even a liberal.
Maybe Ryan is the liberal.
Ryan's just afraid.
Yes?
Could we just draw them as 2 separate models where we need like arrows connecting them or like brackets to say?
Sometimes I see this, just arrows like that showing that they're interchangeable.
But you don't need brackets.
No.
Does
No,
it
no.
ever-
Brackets are for when you have lost or gained electrons.
Does it ever prefer one side over the other? Like ever? Like,
Okay, I've been teaching chemistry now for 26 years, and I have learned to never use the words ever or never.
okay.
So I wouldn't be surprised if somewhere, somehow, there is a resonating molecule that for whatever reason there is a structure that it prefers. What they're able to do with these structures is, I think with a spectrophotometer, they're able to determine which one has a double bond. And what they're reading, what they would get from here is it would be a 50-50. So that leads them to think that it's flittering back and forth. And if you have 3 structures, you would get 33%, 33%, 33%. But I would not put it past chemistry to have some structure where it's 75-25. And I don't know what the explanation would be for that because I don't really understand the explanation for this one. Okay? I can make it work, I can predict it, but beyond that. Mortal. NO positive. What do you think the positive means? Which one? Gained or lost? Which one? Gained or lost? What does plus 1 mean? Okay, now let's just say we don't know. Okay, so let's see what happens. Nitrogen. Since we don't know whether that means gained or lost, let's just ignore it. 5. Oxygen equals. All right, that should give you pause right there, because how many of these have we done that had an odd number of electrons? None. All right, who's in the middle?
Either one.
In this case, it's either one. If it was an H, I definitely would not have said H. 2, 4, 6, 8, 10, 11. No, wait. 10, 11. Okay. Now can you tell me what the plus 1 means? Minus 2 means you gain 2. Plus 1 means you lose 1. Remember, whatever you think is possible, whatever you think is naturally should be the interpretation in chemistry, go opposite. Go the opposite way. So I know that everything screams inside of you, ever since you were a little kid, that plus 1 means you have gained 1. In chemistry, go, you lose 1. Neither did anyone else. Don't fool yourself. All right, so nitrogen is happy, but oxygen is not. Can we double bond here?
No, you
Wait.
Yes.
Can we?
This is what happens when you have too many concussions as a quarterback. Okay. So the answer is yes. Okay. Now is everyone happy? Now is everyone happy? Okay. Is this correct now? Are we done? Very good, mortal. And? Very nice. Very nice. All right. Any questions so far? Molly, thank you for volunteering to do this one, NO3. Go. Plus? Times? Plus or minus? How many? Plus how many? Who's in the middle? 2, 4, 6, 8, 10, 12. Don't go in the middle. Save the middle for last. 12, 14, 16, 18, 20. No, I think that's 22, 24. Done. Everyone happy? What do we do, Molly? With which one? Who are you going to offend? If you choose the one on the left, and what does that even tell you? Molly, what does it tell you? That you're having to decide to see which one gets offended. Yeah. Okay. So somebody's going to be offended. 2 people are going to be offended because you chose which one first. Left, right, or in the middle? Oh, Marco.
Bam.
Are we done now?
Knocked out.
What do we need? And? Natalie's offended, or is it Phoebe? Phoebe's offended. Phoebe's offended. Now what do we do? What? With which one? What about our libertarian friend back there? She's offended now.
Are we gonna have like? Are we gonna have like quizzes over this?
Yeah.
No, like we had the.
Yeah, paper quizzes. Yes.
Like the reaction prediction quizzes.
Yes. Sí. In Spanish. I guess you weren't understanding my yeses. But I need to finish all of it. So once I finish all of it, I'll give you a structure and I'll say, draw it, shape it, hybridize it, angle it, family it, and shape. And okay, I already said shape it. Okay.
We haven't learned about this, have we?
No, we'll start learning it tomorrow.
I think I just wet my pants.
All right, you get to wet your pants by doing this one. Here we go. Okay, first of all,
Wet your pants.
ask yourself, is this ionic, covalent, or both? First of all, if it's ionic, do you have a metal, non-metal? Is magnesium a metal? Okay, it's ionic. Therefore, it cannot be covalent. Covalent is non-metal, non-metal. Could it be both? Is the metal bonded to a group of nonmetals? Okay, so this is a group of nonmetals that we need to draw just like we've drawn before, but we need to add it to this. Okay, magnesiums. We have 3 of them. Are they things that give electrons or do they take electrons? Give. Okay? So are we going to have any electrons around here or are they going to be completely naked? Okay, normally they have 2 electrons. Are they going to give those 2 electrons? Okay, so we put them in brackets and they are denuded. That means they have no clothing on. They are naked. So that means you have 6 electrons to play with here that are gone. Okay? How many phosphates do we have? And how many electrons do we have to split between those? 6. Okay, so here we go. P. How many how many electrons? O.
6 times 4.
And magnesium, the 3 magnesiums are able to give you 6 electrons, so let's split them in half. Who's in the middle? Okay, my dear, magnesium's already on here.
Okay, well, I was double checking if you knew what you were doing.
Oh, I do know what I'm doing.
I don't think you do, but okay, that's possible.
Okay. And 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32. Done. Is everyone happy?
Pretty much, yeah.
How do we complete this?
Bracket. Wait, is that half?
And how many electrons did it gain?
No, 3.
Where'd you get this?
And guess what we're going to have to draw again?
You can't just put like a little subject at the bottom.
No.
Oh.
Are you?
Is there such thing as like a quadrant?
No.
Where did you get this root from?
Oh, it's because it's already on the, right? Yeah.
But you can have like
3 magnesiums will give you 6 electrons. Not only that, but if you look up PO4 on the back of your periodic table, what's the charge?
Okay.
Minus 3.
I got it now.
So it's going to take 2 magnesiums. 1 magnesium cannot satisfy 1 phosphate. 2 magnesiums, now the magnesiums are not satisfied, so you need another phosphate. Finally, you need a 3rd magnesium to satisfy 2 phosphates. And this whole monstrosity is the answer.
That whole thing?
Yep, all of it.
Awesome.
Do question number 3 for homework.
Did you give a worksheet?
Last one. Before snowpocalypse.
Please for some information about a bus change. If you normally ride